We're going to talk about negative angle identities, or sometimes otherwise known as even-odd property. And this applies to other functions besides trig functions, but we will either refer to it as negative angle identities or even-odd properties. And the question is, what happens when you find sine of, say, the opposites of an angle measure? So instead of finding sine of 30, is there a relationship between sine of 30 and sine of negative 30? Well, if we recall, the acronym All Students Take Calculus allowed us a quick way to remember which trig functions were positive in which quadrant. So for example, all trig functions in the first quadrant are positive, only sine is positive in the second quadrant, tangent in the third, and cosine in the fourth. So when I'm talking about sine of negative 30 degrees, so this is negative 30 degrees, negative revolution, sine is negative in that quadrant, so it's the opposite of what sine of 30 is, which is positive in the first quadrant. So 30 degrees is in the first quadrant, sine of 30 is positive, so sine of negative 30 being in the fourth quadrant is the opposite in sine of that, so negative 1 times sine of 30. The same can be true if we look at sine of negative 150 degrees. So actually, let me switch colors so we can color coordinate this. So let's say we have sine of negative 150 degrees. If we went sine of negative 150 degrees, that would be in the third quadrant. And sine of negative 150 degrees is, again, opposite in sign from sine of positive 150 degrees. So in conclusion, when we're trying to find sine of the negative angle measure, it's always opposite in sign. And that is true of things that are odd. For example, let's say y equals x cubed is an odd function. If I were to plug in a negative x into this, I would get that if I cube negative x times negative x times negative x is the opposite of positive x cubed. So we call that an odd function. So sine is what we call an odd function. And for the negative angle identity above there, you can write that the conclusion is kind of like, think of it as you pull the negative out of inside the parentheses to say that it's the opposite in sign to the positive angle measure. So negative sine of theta. So let's see what happens with tangent. Okay, so let's say we were asked to find, and I'll go with one color. We'll just do one on this one, tangent of a negative 135 degrees. So 135 degrees is 45 degrees away from 180 degrees in the second quadrant. Tangent in the second quadrant is negative, whereas tangent of negative 135 degrees, which is in the All Students Take Calculus in the third quadrant, that's positive. So negative 135 degrees. Tangent is positive versus negative in the second quadrant. So our conclusion is that it's the opposite in sign. So one's positive, one's negative, to the positive angle measurements. So tangent of negative 135 is equal to negative tangent of 135. So what that means is that if we define it the same way as we did above, it's an odd. It's also odd, similar to x cubed and similar to sine. So up above there, if I'm asked for tangent of negative theta, I can simply think of it as negative 1 times tangent of the positive angle measure. Okay, now let's see what happens when we do cosine. So with cosine, we know when we're asked for cosine of negative 45 degrees, that puts us in the fourth quadrant. And we know cosine is positive in the fourth quadrant. How is that related to cosine of 45 degrees? Well, they're both positive in the first and the fourth quadrant, so therefore they're equal to each other. There's no need to multiply it by that negative 1. They're the same signs. They're both positive in the first and in the fourth quadrant. So when asked for cosine of negative theta, we simply kind of think of it as drop the negative sign, and it's the same as cosine of theta. This is true of other functions like y equals x squared, where the squared, if I were asked for what is f of negative x for y equals x squared, where f of x is x squared. If I square out negative x times negative x is positive x squared. And so we end up back at the original, versus if I did x cubed, I end up the opposite in sign from the original. So when something like that happens, this is called an even function. So cosine of negative theta is also displays properties of an even function. So when you're finding an angle measure that is negative, and you come out with a value that is the same as if you would find the trig value with a positive angle measurement, then we consider that an even function. So back at the very beginning, sine and tangent have opposite in values of the positive angle measurement, whereas cosine of negative theta is equal to the same thing as the original cosine of theta.